Alright, so if x is going to 2, x squared would be going to 4, plus 2 would be 6. Alright, so again we are going to find a delta greater than 0. Alright, so how did we start earlier? We started by setting up the two inequalities from the definition. Exact same setup. So the first inequality and the second minus L. Then what did we do? We factored x minus c out of our f of x minus L. Same thing. So we have our x minus c factored out. Earlier, in the linear case, we had x minus c, but we just had a constant here. And what we ended up doing, we ended up dividing by that constant. Here we have our x minus c, but we have this function of x here. And it is illegal to divide over by that function of x. So we somehow need to do something to bring this case back to a constant times our x minus c. So we kind of need to replace absolute x plus 3 with just a number. So now we need some number bigger than this. So what we do is we bound delta less than or equal to 1. So what this means is bounding delta less than or equal to 1 means we're only going to look 1 unit to the left of right of c. So we're going to look 1 unit to the left and right of 2. So we should be looking between 1 and 3. So we can see that by taking our delta back to the delta inequality and manipulating. You cannot manipulate with absolute value bars on it. To get rid of them, you have to take this number, the negative of it, to the other side. Okay. All right, so now we need something bigger than absolute x plus 3. So what do you do to an x plus 2? To get to an x plus 3, you would have to add 5. So add 5 to your inequality. So we have this number, x plus 3. It lives between 4 and 6. Any number between 4 and 6 will have an absolute value less than 6.
How'd you decide to add 5?
Well, what do you do to an x minus 2 to get to an x plus 3? You would have to add 5. All right. So earlier we decided we needed some number bigger than the absolute value of x plus 3. Well, we now have that number at 6. So we go back to this statement. I'm going to call it star. We have absolute x plus 3 times absolute x minus 2 is less than. All right. What is bigger than the absolute value of x plus 3? The number 6. What is bigger than the absolute value of x minus 2? That would be delta. So I'm saying the product of the two small sides, the absolute x minus 2 and the absolute x plus 3, will be less than the product of the two large sides, delta and 6. So now we have our f of x minus L less than 6 deltas. We want it to be less than epsilon, so we simply set our 6 deltas equal to epsilon and solve, and we end up with epsilon over 6. But this is not the entire answer. Because remember, this has to work for every epsilon greater than 0. So if they give us an epsilon of 12, this equation will reduce down to delta equals 2. But delta equals 2 contradicts our bound. So the way we fix this problem is at the end we take delta to be the minimum, or the smaller, of our bound and what we would get with the algebra.